With all the above components, a mass spectrometer should produce ions from the sample in the ionization source and should separate these ions according to their mass by charge ratio, um, and the fragments should be analyzed by second analyzer, and all those ions, fragment ions, should be detected. And the spectrum is the M by E versus abundance of all the fragment ion. Mass spectrum, it is the graph, it is the record of masses and the relative abundance of molecular ion and the positively charged fragments formed from it by electron bombardment. The spectrum consists of parent ion peak, base peak, metastable ion peaks. Parent ion peak is the peak obtained for the mass of parent ion. The stability of the parent ion decides its relative abundance. In some cases, the parent ion peak may not be formed. So, in such cases, the rate of decomposition of the parent ion will be so high, so that it is not detected. The rate of decomposition of parent ion increases with the molecular size. The relative height of the parent peak decreases in this following order. So for aromatics, the parent ion peak will be greater because such ions are stable. For alcohol, the height of the peak, parent ion peak, is very less, sometimes may not be detected. So base peak is the tallest peak in the spectrum. So sometimes the molecular ion peak may be the base peak, but it is not always. The fragment ion, if any fragment ion is more abundant, stable, its peak may be the base peak. Metastable ions, metastable peaks. Sometimes fragmentation takes place during the flight rather than in the ionization chamber when it has been sorted out according to M by E value during the flight. So in that chamber, some ions may be produced. So such ions are known as metastable ions. They have lower kinetic energy than the normal ions. The peaks due to these ions have the following characteristics. They do not necessarily occur at integral M by E value or M by Z value. These are much broader than the normal peaks. Nitrogen rule. Nitrogen rule states that a molecule of even numbered molecular mass, that is, if a molecule has got its molecular mass to be an even number, okay, then that means the molecule may have even number of nitrogen atom or no nitrogen. If the molecular mass of a molecule is odd number, then it may have nitrogen atom in odd number. So for example, you take methane, no nitrogen present, mass number 16, which is an even number. Here methanol is mass number is 32, even number, so no nitrogen present. 2 nitrogen present, the mass number is even here for hydrazine. Okay, so if the mass number is even, it may not contain, the molecule may not contain nitrogen, or it may contain odd even number of the nitrogen. If the mass number is odd number, then the number of nitrogen present may be odd. So that is the nitrogen rule. So this is the mass spectrum of water. Molecular mass is 18, so this is the base peak, highest peak, and this is the molecular ion peak also. So there is a peak around 17, so which is for OH plus, small peak at 16 for O plus. So at 19 is for OHD, so deuterium, which is an isotope of hydrogen. So at 20 may be the peak for OH2, where O is the isotope, atomic number 18, isotope of oxygen. So this is the spectrum, mass spectrum of methanol. So the highest peak is here. So the molecular ion peak is the base peak here. So there are peaks for CH2, OH plus, COH plus. There are peaks for methyl ion, CH3 ion, like that. So this is the mass spectrum of toluene. So what happens here? First, from toluene, the H plus ion is left to form benzyl cation, and the benzyl cation is transformed to cycloheptatrienal cation, which is also known as tropylium ion, which is get converted to cyclopentyl cation. So there are peaks around 92, 91, and then 65. 92, peak at 92 corresponds to molecular ion peak, which may be the base peak, if because aromatic, right? So this molecular ion peak will be stable. So this must be the base peak. For benzyl cation, peak around 91 is obtained, and then for cyclopentyl cation, peak around 65 is obtained for toluene. So now let's see about McLafferty rearrangement. So this occurs in the case of molecules like amines, aldehydes, ketones, unsaturated compounds, substituted aromatics and all, which has got the gamma hydrogen in it. So this rearrangement, it involves cleavage of beta bond followed by gamma hydrogen transfer. So in this molecule, which may be a ketone, okay, so this is the gamma hydrogen. So this is alpha carbon, this one is a beta carbon, this one is a gamma carbon. The hydrogen in the gamma carbon is a gamma hydrogen. So gamma hydrogen transfer occurs, and this is the beta bond. This is the alpha bond to C double bond O. This is beta bond. This gets cleaved. So the McLafferty rearrangement, it involves cleavage of beta bond followed by the transfer of hydrogen to the electronegative atoms such as oxygen. The rearrangement leads to elimination of neutral molecules from these kinds of molecules. Generally, a molecular ion with an even mass value cleaves to give fragment ions with the odd mass values, and vice versa. But if the even mass molecular ion, that is molecular ion is whose molecular mass is even, it will yield the fragments which has got the molecular mass to be even. And if the molecular mass of molecular ion is odd, then the fragments also will have the odd molecular mass. So if this is that, then that means there is a rearrangement has occurred. So butanol. So this shows the rearrangement in the butanol, McLafferty rearrangement. So this one is the gamma hydrogen here. This is the beta bond, so it gets cleaved, and there is an